Imagine for a moment that you're standing on a beach at night. The sand is cool beneath your feet, the waves crash in rhythmic certainty, and above you, the cosmos unfolds in all its terrifying magnificence. Billions upon billions of stars pierce the darkness, each one a sun, many harboring worlds we'll never touch, never see, never know. Now ask yourself this: what if you could hold all of that in the palm of your hand? What if humanity could harness not just the energy of our sun, not just our planet, but entire galaxies? What if we could become something so powerful, so technologically advanced, that we would be indistinguishable from gods to our ancestors? This isn't science fiction. This is the Kardashev scale, and it measures something profound: the technological advancement of civilizations based on their energy consumption. And here's the disturbing truth: by this measure, we aren't even a full civilization yet. We're still crawling in the cosmic dirt, reaching for something we can barely comprehend. In 1964, a Soviet astronomer named Nikolai Kardashev was grappling with a problem that had haunted humanity since we first looked up at the stars and wondered if we were alone. How do you search for alien civilizations? More importantly, how do you recognize one if you find it? Kardashev was working on the Soviet SETI program, searching for signals from the cosmos, and he realized that any civilization capable of sending signals across interstellar space would need tremendous amounts of energy. So he did something brilliant and simple. He created a scale, not based on culture, not based on politics or philosophy, but based on the one thing that defines technological progress more than anything else: energy. The ability to harvest it, store it, and use it. Energy is everything. It's the currency of the universe, the fundamental resource that separates a species huddling around campfires from one that can reshape reality itself. Kardashev proposed 3 types of civilizations. Type 1. A planetary civilization that can harness all the energy available on its home planet. Type 2. A stellar civilization that can harness all the energy of its star. Type 3. A galactic civilization that can harness the energy of an entire galaxy. When you first hear this, it might sound like a simple progression, like climbing stairs. But each step is a chasm so vast, so incomprehensibly large, that it makes the gap between a single-celled organism and a human being look trivial. Each level requires not just incremental improvement, but fundamental transformations in technology, society, and our understanding of physics itself. Let's start with Type 1, because this is the first rung on the ladder, the one we're desperately trying to reach. A Type 1 civilization has complete mastery over its planet. They control the weather, they prevent earthquakes, they mine the oceans, the atmosphere, and the planetary crust with perfect efficiency. Every drop of geothermal energy, every gust of wind, every ray of sunlight that touches their world is captured and utilized. Think about that for a moment. Picture Earth, but with zero waste, zero inefficiency. Hurricanes are dissipated before they form, or their energy is captured and stored. Volcanic eruptions are predicted centuries in advance and either prevented or their energy harvested. The entire planet becomes a machine, perfectly optimized for energy collection and use. Carl Sagan, the great science communicator who made the cosmos accessible to millions, later refined the Kardashev scale to include intermediate values. By his calculations, humanity in the 1970s was approximately a Type 0.7 civilization. We've improved since then. As of the early 21st century, various estimates place us somewhere between Type 0.72 and 0.73. We're not even Type 1 yet. We're a Type 0 civilization, still burning dead plants and animals from millions of years ago, still fighting wars over patches of land and barrels of oil, still poisoning our own atmosphere with the waste products of our primitive energy systems. Here's a fact that should make you pause. Humanity currently uses about 18 terawatts of power continuously. That's 18 trillion watts, running every second of every day. It sounds like a lot, doesn't it? But to become a Type 1 civilization, we would need to use approximately 175,000 terawatts. roughly 10,000 times more energy than we currently consume. And that's just type 1, just planetary mastery. We're not even close. Physicist and futurist Michio Kaku estimates that, at our current rate of progress, it will take us roughly 1 to 200 years to reach type 1 status. 200 years. That's assuming we don't destroy ourselves first, assuming we can overcome the challenges of climate change, resource depletion, and our own tribalistic tendencies that keep us divided into competing nations rather than united as a species. But let's be optimistic for a moment. Let's imagine we make it. Picture Earth in 200 years. Fusion power plants, landscape. Their clean reactions producing limitless energy from seawater. Solar arrays in orbit beam power down to receivers on the surface. The Sahara Desert is covered in solar panels. The ocean studded with wave energy converters and offshore wind farms. Every building is a power generator, its windows made of transparent solar cells, its walls embedded with thermoelectric generators that convert heat differentials into electricity. Humanity has become a single, unified civilization, because you can't achieve type 1 while fighting among yourselves. The energy requirements alone demand global cooperation, unified infrastructure, and the pooling of resources on a planetary scale. Ask yourself this: do you think we can do it? Can we, as a species, overcome our differences long enough to achieve this? Can we stop seeing ourselves as Americans, Chinese, Europeans, Africans, and start seeing ourselves as Earthlings, as one civilization among potentially countless others in the cosmos? Now let's talk about type 2, and this is where things start to become truly alien to our current understanding. A type 2 civilization has complete mastery over its star. Not just the light that happens to fall on their planet, but all the energy the star produces, radiating out in every direction. Our sun, Sol, produces about 386 billion megawatts of power every second. Most of it shoots off into empty space, wasted, heating nothing but the cosmic void. A Type 2 civilization would consider this intolerable. They would capture it all. In 1960, Freeman Dyson, a British-American physicist and mathematician, proposed a concept that has haunted science fiction ever since: the Dyson sphere. Imagine a structure that completely surrounds a star, a shell or swarm of collectors that intercepts every photon the star emits. The scale is almost impossible to comprehend. Our Sun has a radius of roughly 700,000 kilometers. A Dyson sphere at Earth's orbital distance would have a radius of 150 million kilometers, a surface area of about 280 quadrillion square kilometers. That's roughly 600 million times the surface area of Earth. To build such a structure, you would need to disassemble entire planets, strip mine asteroid belts, and develop construction techniques that make our most ambitious engineering projects look like children playing with blocks. And here's where it gets interesting. We've actually looked for Dyson spheres. Astronomers have searched for their signatures, the telltale signs of a star whose light has been completely or partially blocked by artificial structures. A Dyson sphere wouldn't be invisible. It would glow in the infrared spectrum, radiating waste heat, because even the most efficient energy collection system can't violate thermodynamics. Some candidates have been found: stars that exhibit unusual dimming patterns or strange infrared signatures. The most famous is KIC 8462852, nicknamed Tabby's star after astronomer Tabitha Boyajian. Between 2011 and 2013, the Kepler Space Telescope observed this star dimming by up to 22%, far more than could be explained by a planet passing in front of it. The dimming was irregular, asymmetric, and unlike anything seen before. The internet exploded with speculation. Could this be it? Could this be evidence of a Type 2 civilization constructing a Dyson sphere or some other megastructure around their star? Scientists proposed alternative explanations: a swarm of comets, a cloud of dust, the remnants of a planetary collision. The most recent data suggests it's probably natural phenomena, but here's the thing that should make your skin prickle: we don't know for certain. We've only just started looking. We've examined a tiny fraction of the stars in our galaxy, And we've already found things that make us wonder. Think about what it would mean to be a Type 2 civilization. You would need to have reached a level of social and technological development where you could coordinate construction projects lasting thousands, perhaps millions of years. You would need material science so advanced that you could build structures in space that make our largest satellites look like dust motes. You would need to solve the problem of entropy, of decay, of system maintenance on a scale that encompasses an entire solar system. And you would need to have survived the transition from Type 0 to Type 1, survived the development of technologies powerful enough to destroy your own planet, survived whatever challenges the universe throws at species that dare to reach beyond their cradle. This brings us to a deeply unsettling question, one that we'll explore more deeply later. If Type 2 and Type 3 civilizations are possible, where are they? Our galaxy is 13.6 billion years old. Earth is only 4.5 billion years old. There should have been time for other civilizations to arise, to develop, to spread. So where is everyone? This is the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked during a lunch conversation in 1950, "Where is everybody?" The silence is deafening. We found no signals, no evidence of alien engineering, no probes, no visitors. Either we're alone, which seems statistically unlikely given the billions of stars in our galaxy alone, or something prevents civilizations from reaching the point where they become detectable. Some call this the Great Filter, a cosmic barrier that civilizations can't pass. The terrifying question is the Great Filter behind us or ahead of us? But let's push forward. Let's talk about Type 3, because this is where the scale transcends anything we can currently achieve and ventures into territory that seems almost magical. A Type 3 civilization has mastery over an entire galaxy. Not just one star, but hundreds of billions of them. They've spread across the spiral arms, colonizing worlds, constructing Dyson spheres around countless suns, creating a network of energy collection and communication that spans light years. The amount of energy available to a Type 3 civilization is almost incomprehensible. Roughly 10 billion times more than a Type 2 civilization, and 100 billion times more than a Type 1. What could you do with that much power? The honest answer is, almost anything that doesn't violate the fundamental laws of physics. You could terraform entire worlds, transforming barren rocks into gardens. You could create artificial worlds, habitats the size of solar systems. You could conduct experiments that probe the deepest mysteries of the universe, smashing particles together at energies that make our largest accelerators look like toys. You might even be able to manipulate space-time itself, creating wormholes for faster-than-light travel or building computers the size of star systems that could simulate entire universes. Some scientists have speculated that a sufficiently advanced Type 3 civilization might be able to access or utilize dark energy, the mysterious force that's causing the universe's expansion to accelerate. Dark energy makes up roughly 68% of the universe's total energy content. If you could tap into it, if you could harness even a fraction of it, the energy available would dwarf even what a traditional Type 3 civilization could access. But this is purely speculative, bordering on fantasy, because we don't even understand what dark energy is, let alone how to use it. Here's something to consider. The progression from Type 1 to Type 2 to Type 3 isn't just about building bigger power plants. Each transition requires fundamental changes in how a civilization thinks about itself and its place in the universe. A Type 1 civilization must think of itself as planetary, as one people sharing one world. A Type 2 civilization must embrace becoming a spacefaring species, spreading beyond their home planet, perhaps even altering themselves to survive in different environments. And a Type 3 civilization must think on timescales that make recorded human history look like a blink of an eye. Stars have lifespans of billions of years. Galaxies persist for hundreds of billions. A true Type 3 civilization would need to plan not in terms of human lifetimes, or even generations, but in terms of geological and cosmic epochs. Can you imagine that? Can you picture a civilization so old, so stable, that it measures time in millions of years the way we measure it in decades. What would they value? What would they fear? Would they even be recognizable to us as living beings? Or would they have transcended biology entirely, uploading themselves into vast computational networks, becoming patterns of information rather than flesh and blood? Let me share some numbers that might help you grasp the scale we're talking about. The Milky Way galaxy contains between 100 billion and 400 billion stars. If a Type 3 civilization built Dyson spheres around just 1% of those stars, that would be 1 to 4 billion Dyson spheres, each one a construction project that would require dismantling multiple planets. The resources needed, the coordination required, the sheer audacity of such an undertaking defies human comprehension. And yet, if the laws of physics permit it, if there's no fundamental barrier, then it's possible. Difficult, yes. Taking millions or billions of years, certainly. But possible. Since Kardashev first proposed his scale, others have suggested extensions. John Barrow proposed a scale that goes in the opposite direction, measuring civilizations by their ability to manipulate smaller and smaller structures. Type 1- could manipulate objects the size of themselves. Type 2- could manipulate genes and complex molecules. Type 3- could manipulate atoms. Type 4- could manipulate atomic nuclei. Type 5- could manipulate individual protons and neutrons. And Type 6- could manipulate the fabric of space-time itself at the smallest scales. By this measure, humanity is already fairly advanced, capable of genetic engineering and atomic manipulation, though we're nowhere near being able to control space-time. Others have proposed higher levels beyond Type 3. Type 4. A civilization that can harness the energy of the entire universe. Type 5. A multiverse-level civilization that can access energy from multiple universes. Type Omega. A civilization that has achieved complete mastery over reality itself, essentially becoming omnipotent. These levels are so speculative, so far beyond anything we can currently conceive, that they're more philosophy than science. But they're fun to think about, aren't they? They push the boundaries of what's possible, forcing us to confront the limits of our imagination. Now let's come back to Earth, literally, and talk about where we actually are and what it would take to reach the next level. As mentioned earlier, we're approximately a Type 0.73 civilization. We're on the cusp, potentially, of reaching Type 1, but we face enormous challenges. The first is energy sources. Our current civilization runs primarily on fossil fuels: coal, oil, and natural gas. These are finite resources, and burning them is causing catastrophic climate change. We're essentially poisoning ourselves to power our civilization, like an addict who knows the drug is killing them but can't stop. Renewable energy offers a path forward: solar, wind, hydroelectric, geothermal. But scaling these up to Type 1 levels requires overcoming significant technical and political hurdles. Solar power is abundant, but it's intermittent and requires huge areas of land or orbital infrastructure. Wind power is clean, but it's inconsistent. Hydroelectric is reliable, but most suitable sites are already developed. Geothermal is constant, but limited to tectonically active regions. We need a breakthrough, something that provides clean, abundant, constant energy. Nuclear fusion is often cited as the Holy Grail, and for good reason. Fusion is the process that powers stars, combining light atoms into heavier ones and releasing tremendous energy in the process. A fusion reactor could theoretically run on hydrogen extracted from seawater, producing helium and energy with no radioactive waste. It's clean, it's safe, and the fuel supply is effectively unlimited. The problem is that we haven't quite figured out how to do it efficiently. Every fusion reactor built so far has required more energy to run than it produces. We're getting closer, though. The ITER project in France, a massive international collaboration, aims to achieve net positive fusion energy by the late 2020s or early 2030s. If it succeeds, it could change everything. But energy is only part of the challenge. To reach Type 1, we need global coordination on a scale never before achieved. Currently, humanity is divided into roughly 195 countries, each with its own government, its own interests, its own agendas. We compete with each other, we fight wars, we hoard resources. This has to change. Not because of some idealistic vision of world peace, though that would be nice, but because the infrastructure required for Type 1 civilization demands it. You can't build a global energy grid if nations are sabotaging each other. You can't optimize planetary resources if everyone is trying to grab the biggest share for themselves. This is where many people become pessimistic. Human history is, in many ways, a history of conflict. We've been fighting each other since we climbed down from the trees. Why would that change now? But here's a counterargument. We've also been cooperating since we climbed down from the trees. We formed families, then tribes, then cities, then nations. Each step expanded the circle of who we considered us rather than them. There's no fundamental reason why that circle can't expand to encompass all of humanity. In fact, the challenges we face, climate change, resource depletion, potential asteroid impacts, they affect everyone. They don't respect national borders. Solving them requires us to work together or fail together. Ask yourself, what kind of world do you want to live in? One where we remain divided, squabbling over scraps as our planet deteriorates, or one where we unite, pooling our knowledge and resources to build something greater than any individual nation could achieve alone? Let's assume, optimistically, that we make it to Type 1. We've solved fusion, we've built global infrastructure, we've achieved some form of world government or at least effective international cooperation. What's next? How do we get from Type 1 to Type 2? This transition is arguably even more difficult than reaching Type 1, because it requires us to become a truly spacefaring civilization. We need to spread beyond Earth, not just with a few explorers or scientists, but with entire populations. We need to colonize other worlds in our solar system and develop the technology to build structures in space on a scale we've never attempted. The first step is probably the moon. It's close, only 3 days away with current technology, and it has resources we can use. Lunar regolith contains oxygen, silicon, iron, aluminum, and other useful elements. We could mine these, process them locally, and use them to build habitats and infrastructure without having to launch everything from Earth. The moon's low gravity makes it an ideal location for a mass driver, a sort of electromagnetic catapult that could launch materials into space cheaply and efficiently. From the moon, we could supply construction projects throughout the solar system. Then there's Mars. Humanity has been dreaming of Mars for over a century, and for good reason. It's the most Earth-like planet in our solar system, with a day roughly the same length as ours, water ice at the poles and underground, and an atmosphere that, while thin, could potentially be thickened through terraforming. SpaceX, founded by Elon Musk, has stated its goal is to establish a self-sustaining city on Mars. Whether that specific plan succeeds or not, Mars will almost certainly be humanity's second home, if we survive long enough to build it. But the Moon and Mars are just the beginning. To reach Type 2, we need to utilize the entire solar system. The asteroid belt contains enormous mineral wealth: iron, nickel, platinum, and rare earth elements in quantities that dwarf Earth's crust. Mining asteroids and processing them in space could provide the raw materials for megastructure construction. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants with dozens of moons, many of which have subsurface oceans and complex chemistry. They could serve as outposts for expansion into the outer solar system. And then there's the Sun itself. Building a Dyson sphere or even a partial Dyson swarm would be the ultimate achievement of a Type 2 civilization. Current proposals don't actually suggest a solid shell, which would be gravitationally unstable and require materials with impossible strength. Instead, a Dyson swarm would consist of millions or billions of independent solar collectors, each one orbiting the Sun, together capturing a significant fraction of its output. We could start small, launching a few collectors as proof of concept, then gradually expanding over centuries or millennia until the swarm was complete. One proposed design is called a Dyson bubble, using solar sails so thin that radiation pressure from the Sun itself would keep them aloft, requiring no orbital velocity. Another is the Dyson net, a mesh of wires or cables supporting collector panels. Yet another is the Matryoshka brain, proposed by Robert Bradbury, a series of nested Dyson spheres, each one using the waste heat of the inner layers, creating a gigantic computational device powered by a star. Imagine that, a computer the size of a solar system, running simulations of such complexity that entire civilizations could exist within it, never knowing they were virtual. This raises a disturbing possibility that philosophers and physicists have debated seriously. Could we already be in a simulation? If Type 2 or Type 3 civilizations can create computers powerful enough to simulate entire universes, complete with conscious beings who experience their existence as real, then there could be vastly more simulated realities than base reality. Statistically, it would be more likely that we're in a simulation than in the original, base universe. This is the simulation hypothesis, and while it sounds like science fiction, serious thinkers like Nick Bostrom have argued that at least one of the following must be true. Either civilizations like ours never reach the point where they can create such simulations, or they reach that point but choose not to, or we are almost certainly in a simulation right now. Think about that for a moment. Look at your hands. Feel the weight of your body, the air in your lungs. Is it real? Or are you a pattern of information running on some vast computer built by beings so advanced that they would seem like gods to you? And if you are, does it matter? If the simulation is detailed enough that you can't tell the difference, is there a difference? Let's step back from the philosophical abyss and return to the practical question of reaching Type 2. One major challenge is time. Even with fusion power, even with asteroid mining and space-based construction, building something like a Dyson swarm would take thousands of years at minimum, possibly much longer. Humanity's current technological civilization is only a few hundred years old. Can we maintain a continuous, focused effort for 10 times that long? 100 times? What if it takes 1,000,000 years? This is where the nature of the civilization itself might need to change. Biological humans have lifespans measured in decades. We're impatient. We want results within our lifetimes. But a project that takes millennia requires a different perspective. Perhaps we augment ourselves, extending our lifespans through genetic engineering or medical technology. Perhaps we upload our consciousness into machines, becoming digital beings that could potentially live indefinitely. Or perhaps we create artificial intelligence, entities that could carry on the work long after we're gone, though that raises its own set of terrifying questions about whether they would still serve our goals or pursue their own. There's also the question of motivation. Why build a Dyson swarm? Why spread across the galaxy? For a Type 0 civilization like ours, the answer seems obvious. Survival, growth, the continuation of our species. But what about a Type 1 or Type 2 civilization? They would have solved material scarcity. Everyone could have everything they need. What drives them forward? Curiosity, the desire to understand the universe, the fear of extinction from some cosmic catastrophe, or something else, something we can't understand because we're not there yet. Now we come to Type 3, and here we enter the realm of speculation piled upon speculation. We have no roadmap for this, no clear path from Type 2 to Type 3. It's not just about building more Dyson spheres around more stars. It's about coordinating activity across a galaxy, across light years of space, across timescales that make even a Type 2 civilization's projects look brief. The galaxy is enormous. Light takes 100,000 years to cross it. Even if you had faster-than-light travel, which physics as we currently understand it says is impossible, the sheer scale is daunting. How do you govern a civilization spread across that distance? How do you communicate? How do you maintain a shared culture, shared goals, shared identity. Perhaps you don't. Perhaps a Type 3 civilization isn't really a single civilization at all, but a network of connected Type 2 civilizations, each centered on a star or cluster of stars, working in loose cooperation toward common objectives. Or perhaps they've solved faster-than-light travel. There are speculative concepts in physics that don't violate known laws but would allow effective FTL movement. Wormholes, warp drives like the Alcubierre metric, manipulation of higher dimensions. All of these require exotic matter with negative energy density, something we've never found and don't know how to create. But a Type 2 civilization, with access to the energy of an entire star and millennia to conduct research, might figure it out. And if they do, the galaxy suddenly becomes much smaller, much more manageable. Here's an interesting thought experiment. If FTL travel is possible and Type 3 civilizations exist, they could have colonized the entire galaxy by now. The Milky Way is old enough that even traveling at a small fraction of light speed, a civilization could spread from one edge to the other in a few million years, a blink of an eye in cosmic terms. The fact that we see no evidence of this is one of the most puzzling aspects of the Fermi paradox. Either FTL is impossible and galactic colonization is too slow and difficult to be worth it, or there's some other factor at play. This brings us to the concept of the Great Filter, which deserves a deeper examination. The idea, proposed by economist Robin Hanson, is that there's some stage in the development of life and civilization that's extremely difficult or impossible to pass. A filter that prevents the universe from being filled with advanced civilizations. The question that should keep you awake at night is, where is the filter? There are several possibilities. Maybe the filter is behind us. Maybe the emergence of life itself is so improbable that Earth is a cosmic fluke, one of a tiny handful of living worlds in the entire universe. Or maybe life is common, but complex multicellular life is rare. Or maybe intelligence is rare. Or maybe technological civilization is rare. If any of these are the filter, then we've already passed it, and the path to Type 3 is open, difficult but achievable. But maybe the filter is ahead of us. Maybe every civilization reaches a point where they develop technologies powerful enough to destroy themselves, and most of them do. Nuclear weapons, bioengineered plagues, runaway artificial intelligence, environmental collapse. There are so many ways a technological civilization could die. Maybe we're currently in the filter, and the next few centuries will determine whether we pass through or join the countless dead civilizations that didn't make it. Or maybe the filter is even further ahead. Maybe there's something about reaching Type 2 or Type 3 that's fundamentally destructive. Maybe harnessing the energy of stars causes some kind of cosmic backlash we don't understand yet. Maybe advanced civilizations inevitably attract the attention of something that destroys them. This is pure speculation, bordering on paranoia, but it's worth considering. The silence of the cosmos is eerie. If the path to Type 3 is possible, someone should have walked it already. So either we're first, which seems unlikely given the age of the universe, or something stops civilizations from getting there. There's another possibility, one that's perhaps even more unsettling. Maybe advanced civilizations are out there, but they're hiding. Maybe they've seen what happens to civilizations that make themselves obvious, broadcasting their presence to the cosmos, and they've gone dark, camouflaging themselves, making their megastructures as undetectable as possible. Maybe the galaxy is filled with silent watchers, civilizations that have learned to keep quiet. If that's the case, why? What are they hiding from? Or perhaps, and this is the most humbling possibility, they simply don't care about us. We search for signals, we look for Dyson spheres, we assume that if intelligent aliens exist, they would want to communicate, to reach out, to explore. But why would a Type 3 civilization care about a Type 0? We don't try to communicate with ants, except as scientific curiosity. Maybe we're so far beneath their notice that our existence is irrelevant to them. Maybe they're all around us, conducting activities we can't even perceive, and we're like bacteria trying to understand humans. Let's explore what a Type 3 civilization might actually look like. based on what we know about physics and engineering. First, they would almost certainly have mastered nanotechnology, the ability to manipulate matter at the atomic and molecular level. This would allow them to build structures with perfect efficiency, no waste, every atom placed exactly where it needs to be. Their Dyson spheres would be built by self-replicating nanobots, swarms of microscopic machines that break down asteroids and planets, atom by atom, and reassemble them into solar collectors and habitats. They would have mastered biotechnology as well, or possibly transcended biology entirely. Why remain bound to fragile flesh when you could upload your consciousness into a machine substrate that's more durable, more adaptable, and potentially immortal? A Type 3 civilization might consist entirely of uploaded minds, living in vast virtual realities powered by matryoshka brains, experiencing eons of subjective time in the span of objective seconds. Or they might go the opposite direction, embracing biology but engineering it to perfection. They could customize organisms for every environment, creating life forms that thrive in the vacuum of space, in the crushing gravity of gas giants, in the searing heat near a star's surface. They could be anywhere, in any form, adapted to every ecological niche the galaxy has to offer. Their understanding of physics would be complete, or as complete as the universe allows. They would know whether string theory is correct, whether there are extra dimensions, what dark matter and dark energy really are. They might have discovered new laws of physics that we haven't even imagined. And with that knowledge comes power, the power to manipulate reality in ways that would seem magical to us. Some scientists have speculated that a sufficiently advanced Type 3 civilization might be able to create new universes, triggering false vacuum decay events that spawn baby universes with different physical constants. They could be universe engineers, crafting realities to their specifications. If this is possible, then somewhere, in some higher dimensional space we can't access, there might be beings who created our universe, who set the physical constants that allow stars and planets and life to exist. Not gods in the religious sense, but entities so advanced that the distinction becomes meaningless. Do you see now why the Kardashev scale is so captivating? It's not just about energy consumption. It's about the trajectory of intelligence in the universe, about what we could become, about whether the cosmos is filled with wonders beyond our imagination or is a cold, dead void in which we're alone. Every answer is terrifying in its own way. If we're alone, the burden of consciousness falls entirely on us. We're the universe's only chance to understand itself, and if we fail, if we destroy ourselves or stagnate, then the cosmos continues in eternal darkness. But if we're not alone, if there are Type 3 civilizations out there, then where are they? And what does their silence mean? In recent years, some researchers have proposed that we should be looking not for radio signals or Dyson spheres, but for signs of stellar engineering on a much more subtle level. A Type 2 or Type 3 civilization might engage in star lifting, extracting matter from stars to extend their lifespans or to use as fuel for fusion reactors. They might move stars, pushing them into more convenient configurations using massive solar sails or directed energy beams, a process called stellar husbandry. They might trigger supernovae in controlled ways, using the explosion to create heavy elements or as a propulsion system for relativistic travel. We should be looking for stars that behave oddly, that don't follow the normal patterns of stellar evolution, because those might be stars under management. There's also the possibility of Shkadov thrusters, a type of megastructure proposed by physicist Leonid Shkadov. It's a giant mirror, positioned near a star, reflecting some of its light back at it. The star's own radiation pressure would slowly push it in the opposite direction. Over millions of years, you could move an entire solar system this way, steering stars around the galaxy like ships. Why would anyone do this? Maybe to avoid a supernova in your neighborhood. Maybe to move your star into a more resource-rich region of the galaxy. Maybe to escape the eventual heat death of the universe by clustering stars together, creating islands of warmth and light that could persist longer than isolated stars. A Type 3 civilization might be rearranging the galaxy right now, moving stars into patterns we interpret as natural but are actually engineered. And then there's the possibility of accreting black holes. A civilization could dump matter into a black hole and extract energy from its accretion disk, or, even more efficiently, from its rotation using the Penrose process. A rotating black hole is, in some sense, a battery of rotational energy. If you drop matter into it at the right angle, you can extract more energy than you put in, slowing the black hole's rotation in the process. A Type 3 civilization might farm black holes, cultivating them, feeding them carefully controlled amounts of matter, and harvesting energy at efficiencies approaching the theoretical maximum allowed by physics. And when the black hole stops rotating, they could wait. In the far future, trillions of years from now, when all the stars have died and the universe is cold and dark, black holes will be the last sources of energy, slowly evaporating through Hawking radiation. A civilization that has learned patience, that thinks in terms of eons, might survive on that thin trickle of energy, the last minds in the universe, persisting until even the black holes evaporate into nothing. This is a deeply melancholic vision, isn't it? The idea that no matter how advanced we become, no matter what heights we reach, the universe will eventually win. Entropy always increases. The second law of thermodynamics is merciless. Even a Type 3 civilization, even beings that harness galaxies, will eventually run out of energy, run out of time, run out of options. The universe will expand and cool, and all complexity, all structure, all life and mind will dissipate into formless heat. This is the heat death, the big freeze, the end of everything. Unless we're wrong about physics. Unless there's a way out we haven't discovered yet. Maybe higher dimensions offer escape routes. Maybe the multiverse is real and we can migrate to younger universes. Maybe consciousness itself is a fundamental feature of reality, not dependent on physical substrate, and can persist in some form even after all matter and energy have decayed. These are desperate hopes, grasping at straws, but for a civilization with billions of years to conduct research, even straws might be worth grasping. Let's bring this back to something more immediate, more human. What does the Kardashev scale mean for us, here, now, today? Why should you care about Type 3 civilizations when you have bills to pay, a job to do, a life to live? Here's why. The scale represents a choice about what kind of species we want to be. Do we want to remain confined to Earth, squabbling over resources, or do we want to reach for the stars? Do we want to risk extinction, or do we want to spread ourselves across multiple worlds, multiple solar systems, ensuring that no single catastrophe can wipe us out? Do we want to remain primitive, or do we want to evolve, to grow, to become something greater? Every dollar spent on space exploration, every advance in renewable energy, every step toward international cooperation moves us closer to Type 1. And Type 1 is the foundation for everything else. If we can't unite as a planet, we'll never unite as a solar system or a galaxy. If we can't manage our own world's resources wisely, we'll never be trusted with the resources of a star or a galaxy. The Kardashev scale is a ladder, but it's also a test. Each level tests whether a civilization has the wisdom, the foresight, and the unity to handle the power it would gain. Think about the technologies we've already developed. Nuclear weapons give us the power to destroy ourselves many times over. Artificial intelligence might soon match or exceed human intelligence in every domain. Genetic engineering allows us to rewrite the code of life itself. These are world-changing, potentially world-ending technologies, and we develop them as a fractured Type 0 civilization. Now imagine the technologies a Type 2 or Type 3 civilization would have. The power to move stars, to create universes, to reshape reality. If we can't handle nuclear weapons responsibly, how could we ever be trusted with that? This is why some scientists and philosophers argue that the Great Filter isn't a single event, but a series of challenges, each one testing a civilization's maturity. Can you develop technology without destroying yourself? Can you achieve abundance without losing purpose? Can you spread across the stars without losing what makes you who you are? Can you become godlike in power without becoming monstrous in deed? These are not easy questions, and the fact that we see no evidence of Type 3 civilizations suggests that passing all these tests might be extraordinarily rare. But here's the thing about humanity. We're adaptable. We've survived ice ages, plagues, wars, and disasters. We've gone from stone tools to spacecraft in a geological eye blink. We've touched the moon, sent probes to the edge of the solar system and beyond, peered into the deepest structures of matter and the furthest reaches of space and time. We've mapped the human genome, eradicated diseases, connected the entire world in a web of communication and information. When we work together, when we focus our creativity and determination, we can accomplish astounding things. So can we reach Type 1? I believe we can if we choose to. It will require sacrifice, cooperation, and a willingness to think beyond national borders and individual gain. It will require us to confront the existential threats we face: climate change, nuclear proliferation, ecological collapse, and actually solve them rather than just worrying about them. But it's possible. The technology either exists or is within reach. The only question is whether we have the collective will. Can we reach Type 2? This is harder to answer. It requires us to become a spacefaring civilization, to spread beyond Earth not just with robots and telescopes, but with living, breathing humans, or whatever we evolve into. It requires construction projects lasting millennia, social stability we've never achieved, and technological breakthroughs we can't predict. But if we make it to Type 1, if we prove we can handle planetary-scale power responsibly, then Type 2 becomes not just a possibility but perhaps an inevitability. Why would we stop? Why would a civilization that has unified its planet and solved its energy problems not reach for more? Can we reach Type 3? This is where even optimism becomes strained. The gulf between Type 2 and Type 3 is so vast, the challenge is so enormous, that it's hard to see a clear path. It might take millions or billions of years. It might require technologies we can't even imagine. It might be impossible, blocked by physics we don't yet understand or by the Great Filter. But if it's possible, if even one civilization in the entire history of the universe can reach Type 3, then it's worth trying. Because the alternative is stagnation, slow decline, and eventual extinction. Better to reach for the stars and fail than to never try at all. There's something profoundly hopeful about the Kardashev scale, despite all the discussions of filters and extinction and heat death. It suggests that progress is possible, that civilization can advance, that we're not doomed to remain as we are forever. It gives us a goal, a vision of what we could become. And perhaps most importantly, it forces us to confront our place in the universe, to ask ourselves the big questions that make life meaningful. Are we alone? Almost certainly not. The universe is too big, too old, too fecund with possibility for Earth to be the only world where life arose. But are we alone in our technological capability, in our time, in our region of space? That's harder to answer. The silence suggests we might be, at least for now. And if we are, then the responsibility falls on us. We're the universe's leading edge, consciousness pushing outward into the dark, trying to understand, trying to survive, trying to build something that will last. What would it feel like to be part of a Type 1 civilization? Imagine waking up in a world where energy is abundant and clean, where everyone has access to education, healthcare, and opportunity, where the scars of industrialization have healed and Earth is carefully managed as the garden it could be. Imagine looking up at the night sky and seeing not just stars, but cities on the Moon and Mars, habitats in the asteroid belt, research stations throughout the solar system. Imagine knowing that humanity has passed the first great test, that we've proven we can unite, we can plan for the long term, we can be responsible stewards of the power we wield. Wouldn't that be worth striving for? What would it feel like to be part of a Type 2 civilization? You might not even live on a planet anymore. You might inhabit a rotating cylinder in space, kilometers long, with its own forests and rivers and sky, indistinguishable from a natural landscape except that it was built, engineered, optimized. You might work on the construction of the Dyson swarm, coordinating with millions of others across decades to place the next wave of collectors. You might be part human, part machine, your consciousness expanded through neural interfaces, able to experience sensory data from across the solar system simultaneously. You might live for centuries, maybe longer, watching the slow unfold of humanity's greatest project. And when you look at the sun, you would see not a remote ball of fire, but the beating heart of your civilization, the source of all you are and all you could become. What would it feel like to be part of a Type 3 civilization? This is harder to imagine because we have no reference, no experiences to draw on. You might not have a body at all, existing as pure information, your thoughts distributed across computational substrates orbiting 1,000 different stars. You might experience time differently, able to speed up or slow down your subjective experience at will, living years in a second or experiencing a millennium in what feels like a lazy afternoon. You might converse with minds that have existed for millions of years, that remember the early days of the civilization's expansion, that have witnessed the births and deaths of stars. You might participate in projects so vast, so long-term, that they reshape the entire galaxy, turning the Milky Way into a work of art, a sculpture in stars and dust that will persist for billions of years. Or maybe you wouldn't be human anymore at all. Maybe by the time a civilization reaches Type 3, it has transcended its origins so completely that nothing of the original species remains except perhaps some core values, some fundamental drives that persist even as the form changes beyond recognition. Maybe humanity's descendants will be as different from us as we are from single-celled organisms. And maybe that's okay. Maybe evolution, both biological and technological, doesn't have a destination, only a direction, toward greater complexity, greater capability, greater understanding. Here's a question you should ask yourself, right now. What can I do to help humanity reach the next level? It might seem like an absurd question. You're one person. The Kardashev scale deals with civilizations, with energies measured in terawatts and timescales measured in centuries. What difference can one person make? But civilizations are made of individuals. Every great work started with someone deciding it was worth doing. You can support space exploration, advocate for clean energy, work to build bridges between cultures and nations rather than walls. You can educate yourself and others about the challenges we face and the possibilities that await us. You can choose hope over despair, cooperation over competition, the long view over short-term gain. These things matter. They ripple outward, influencing others, changing the culture, shifting the trajectory, if only by a tiny amount. But tiny amounts, compounded over time, can steer us toward the stars or into oblivion. We're living in a pivotal moment in human history. For the first time, we have the technology to destroy ourselves completely, whether through nuclear war, engineered pandemics, or runaway climate change. But we also have, for the first time, the ability to spread beyond Earth, to establish backup copies of human civilization on other worlds, to begin the long journey toward Type 1 and beyond. The next few centuries will determine which path we take. Will we pass through the Great Filter, or become another silent civilization, a brief flicker of consciousness that sparked and died? The physicist Carl Sagan once said that we live in an age of startling possibilities, that we are the first generation capable of either destroying civilization or taking it to the stars. That was in the 1980s, and it's even more true now. The tools are there. The knowledge exists or is within reach. The only missing ingredient is the will, the decision, conscious and collective, that we want to survive, we want to grow, we want to become more than we are. Let me leave you with one final thought, one last image to carry with you. Imagine Earth, billions of years from now. The sun has aged, swollen into a red giant, its outer layers expanded beyond the orbit of Mercury, perhaps even Venus. But Earth survives, carefully moved to a safer orbit by technologies developed over millions of years. The planet is unrecognizable, transformed by eons of habitation and engineering into something both strange and beautiful. And surrounding the sun, catching every photon it emits, is the Dyson swarm, billions of collectors maintained by entities that are humanity's descendants but might not call themselves human anymore. They remember, though, encoded in their deepest archives, they remember where they came from, a single planet, a species that learned to make fire and tell stories and ask questions about the lights in the sky. They remember the first tentative steps into space, the struggles to reach Type 1, the long patient work of building the swarm. And maybe, encoded in those same archives, is a record of this moment, right now, when humanity stood at a crossroads and chose the harder path, the one that led upward. Wouldn't you like to be part of that story? Wouldn't you like to know that your life, however small it might seem, was part of the foundation on which a Type 3 civilization was built? The Kardashev scale isn't just a measurement of energy consumption. It's a map of possibility, a glimpse of what intelligence can accomplish when given enough time and determination. We may never reach Type 3. The challenges might be too great, the filter too strong, the universe too hostile. But we can try. We can reach for Type 1, then Type 2, then maybe, just maybe, we can become beings of such power and wisdom that the galaxy itself becomes our canvas. And if we fail, if we fall short, at least we will have tried. At least we will have looked up at the stars and said, yes, we want that. We want to grow, to explore, to understand, to become more than we are. That's what the Kardashev scale offers us. Not a guarantee, but a challenge. Not a destination, but a direction. The question isn't whether we can reach Type 3. The question is, are we brave enough to try? Are we wise enough to survive the attempt? Are we united enough to work together across generations, across centuries, toward a goal we might never personally see achieved? The universe is vast and ancient and filled with mysteries we've barely begun to explore. Somewhere out there, maybe, are the Type 3 civilizations, the galaxy-spanning empires of energy and intelligence. They're not talking to us, not helping us, not making themselves obvious. Maybe they can't, maybe they won't, maybe they don't exist. But their silence, their absence, leaves a space for us to fill. We could be the first, the ones who figure it out, who pass through all the filters and reach heights no other civilization has achieved. Or we could be the latest in a long line of species that tried and failed, that burned brightly for a moment and then faded into cosmic dust. Which will it be? That depends on choices we make now, today, this year, this century. It depends on whether we can overcome our divisions, our short-sightedness, our tendency towards self-destruction. It depends on whether we can grow up as a species, mature from a fractious Type 0 into a unified Type 1, and then keep going, keep reaching, keep building. The path is long, the challenge is enormous, the outcome uncertain. But the potential, the sheer possibility of what we could become, makes it worth every risk, every sacrifice, every ounce of effort we can muster. So when you look up at the night sky tonight, don't just see distant suns. See potential. See energy waiting to be harnessed. See worlds waiting to be settled. See a galaxy waiting for intelligence to take root and spread and flourish. And ask yourself, will humanity be part of that future? Will we reach Type 1, Type 2, maybe even Type 3? Or will we remain here, on this single fragile world, until some disaster, cosmic or self-inflicted, erases us from existence? The answer isn't written yet. We're writing it now. With every choice we make, every technology we develop, every bridge we build between peoples and nations. The Kardashev scale is waiting. The universe is waiting. And somewhere, perhaps, among the billions of stars and billions of galaxies, other civilizations are waiting too, wondering if they're alone, if anyone else will join them in the cosmic community of Type 2 and Type 3 civilizations, if the universe will ever be truly alive with intelligence and purpose and meaning. We could be the answer to their question, just as they might someday be the answer to ours. We could meet, compare notes, share knowledge, build something together that neither civilization could achieve alone. Or we could remain silent, another potential unfulfilled, another voice that never joined the chorus. The choice, terrifying and exhilarating in equal measure, is ours to make. And the clock is ticking.